This is our second example. Example number 2. How much in grams of C2H6 or ethane is needed to react with 20 grams of oxygen? Assume a complete reaction in 100% yield. Alright? So we don't have a chemical equation. So therefore, we need a chemical equation. So since this is combustion, because a hydrocarbon is reacting with oxygen. So we have C2H6 plus O2. And what are the products of combustion? Yes, that would be carbon dioxide and water. Now, we don't have a balance equation, so we balance the equation. So, let's account for the number of atoms. So let's account first the number of atoms in the reactant side. So we have 2 for carbon, 6 for hydrogen, and 2 for oxygen. How about in the product side? We have 1 carbon, 2 hydrogen, and 2 plus 1 oxygen atoms. Alright, so let's balance carbon first. So to balance carbon, we're going to have a multiplier of 2, which is also our coefficient for CO2. However, here, the oxygen in CO2 was affected, so that would be 2 times 2 already. So, we also have to multiply this by 2, making 4. 2 times 2, 4. Alright, so we balance C already. How about hydrogen? Okay, so that's 6 and 2. So to balance, I have to multiply this by 3. So I have to put 3 as coefficient beside water. So we already have balance H. Now how about, here, oxygen was affected, so we have to multiply this by 3. So we have balanced carbon and hydrogen. How about oxygen? We now have 2 times 2, 4 plus 3. So we have 7 oxygen atoms. So to make this 7, so we have to multiply this by 7 over 2. So you multiply O2 by 7 over 2. But from our previous examples in balancing chemical equation, this 7 over 2 is not allowed. So what do? You multiply everything by 2. So your equation now will be 1 times 2. So 2 C2H6 plus 7 over 2 times 2, 7O2. 2 times 2 is 4, 4CO2 plus 3 times 2, 6H2O. So you now have a balanced combustion reaction of ethane. Now, since we have a balanced equation already, we can now solve for our problem. So you are given 20 grams of O2. So let's write that as our given. 20 grams of O2. Now you have another conversion factor here. So since you want to convert grams to mole, you need the formula weight of O2. So what's the formula weight of O2? From the periodic table, the atomic weight of O is 16. But since you have 2, so that would be 2 times 16. So the formula weight of O2 is 2 times 16. So that's 32 grams per mole. Now let's put it in your conversion factor. Let's put this in your conversion factor. So to cancel grams, you have to put 32 grams O2 in the denominator and 1 mole O2 in the numerator. So you can cancel gram. Now since your unit is already in mole O2, you can now use the mole ratio. So since this means that there are 2 moles of ethane reacting with 7 moles of O2, that is your mole ratio. 2 is to 7. So for every 7 mole of O2, 2 moles of this is produced. Or I mean is reacting. Alright? So that's 20 times 2 divided by 32 divided by 7. However, we're not yet done because this is still in moles. We need the mass. So, what do? We have to get the formula weight of C2H6. Alright? So, we have to account the number of atoms. So, for carbon, we have 2 atoms times 12. For hydrogen, we have 6 atoms times 1. So, you just get the sum of the products. So, that would be 2 times 16 plus 6 times 1. Sorry. So, the formula weight of C2H6 is 38 grams per mole. Alright, so here, you put 38 grams C2H6 here and 1 mole of C2H6 here. So, why am I doing that? So that I can cancel the units. So, this is just dimensional analysis. So, now you perform the necessary calculation. So, that would be 20 times 2 times 38. So, 20 times 2 times 38 divided by 32, divided by 7, divided by 1. So, you don't include 1 anymore. So, divided by 32, divided by 7. Alright? So, this is our answer. The answer is 6.785. But again, you have to express in correct SF. So, express in 3SF. So, the answer is 6.79 grams C2H6. Alright, so this is our final answer. So, meaning 20 grams of oxygen will react completely with 6.79 grams of C2H6 if the reaction is complete and there is a 100% yield.